Okay, lesson one, geometry terms. If you have these notes printed out, you could fill them in, or else you'll have to just write them out on your own in your own notebook. I'm just going to write them out from scratch here, so you can just follow along with me and copy them down in your notebook if you don't have a way of printing them. All right, I'm just going to go through the basic terms here that you need to know to get started out here. Points, and I'll try to keep it things as concise as possible. Single location in space, and we'd say like this, point A, and we draw it like this. A line extends forever in two directions. Okay, so like this, we put arrows on the end to show that it extends forever in two directions. When we name it, we got to name 2 points that are on the line. So we'd say line AB. Okay, or we'd say AB with a little line over the top of it. That would be another way to say it. Okay, but you need 2 points to name a line so we know which direction it's heading. A line segment, or segment, might just call it a segment also. It's 2 endpoints. And all the points between. All right, so 2 endpoints, say C and D, and then all the points between. So we just we fill it in between with a line segment. We'd call it segment CD or DC. The order doesn't really matter. Or you could say CD with a little segment over the top of it. Okay, so that still has infinite points. It's just that it has 2 ends, but there are infinite points between. This also has infinite points, but it keeps going out. But I could draw as many points as I wanted between here. A ray has an endpoint and extends in one direction. Okay, so maybe like whatever, we'll say EF. Okay, has one endpoint E, and then it extends infinite points in one direction. So we'd say ray EF, or we put EF with a little ray over the top of it. Say the ray points this way, or let's say that's JK. Okay, what would we call this ray? Well, you always name it with the endpoint first. We're actually going to call this ray KJ. Or KJ with the ray over it. Okay, we always put the endpoint first, and then the point it goes through second. Plane is a flat surface. It also extends infinitely. Let's say extends infinitely, which, you know, how we draw that is we draw like a parallelogram like this. That's representing a flat surface. It technically keeps going out. So this keeps going out this way, this way, this way. But to draw it, we just put these border lines on it. To name it, you need to have at least 3 points. Generally, we'll always just name it with 3 points that are on the plane. So if I draw 3 points on that plane, A, B, and C, I would just call this plane ABC. Any 3 points on that plane can name it. You need 3 points to name a plane. If you only had 2, it wouldn't be clear what direction the plane is facing. Okay. Quick example on that, here's, say we draw a cube like this. A, B, C, D, E, F, G. Okay, what would I name this plane over here? This face here. Well, You just need 3 points that are on it. I could say BCD, BC and D. I could also call it plane CBG. There's many different names. I just need to say 3 points, but you can see as long as I name 3 points, then it's clear that I'm talking about this plane here. Okay, and a couple other things here, collinear. You can see the word linear in there, right? Just means on the same line. Okay, so points are collinear, means they are in a line. So we'd say A, B, and C are collinear. Even if you didn't draw the line there, they could be collinear as long as you could draw a line that goes through them. So we'd say A, B, and C are collinear. Okay, they're on the same line. Look up here, A, B, and C, not collinear. I can't draw a line that goes through all 3 of them, non-collinear, okay? And last thing is coplanar, which you probably can guess is on the same plane. Okay, so, you know, we could say up here, you know, G, B, and C are coplanar. They're on the same plane. And the funny thing is any 3 points actually are coplanar. If you really visualize it, we could say any 3 points are coplanar, but in general, you know, coplanar just means they're on the same plane. Okay. So J, oops, K, and L are coplanar. Okay, but actually any 3 points are actually always coplanar, if you can visualize that. And 4 points don't have to be coplanar. You could have 3 points here and then 1 point up here, call it M. Okay, and then we say J, K, L, and M are not coplanar because they're not all in the same plane. Okay, and then actually I lied, one more thing here, guys. Intersecting, which you probably know intersecting from previous experience, but we'd say lines can intersect, obviously, at a point. Just be really specific, you know, line AB, line CD, say they intersect here at E. So we could say CD line intersects BA, line BA, put the line symbol at E, point E. You can say point E or just say E, that's fine. If you have 2 planes that intersect, if we look, let's see, I guess I'll redraw this quick. This is the same picture that's up above, so if you don't want to redraw it, you probably don't have to. That same cube. So I could say planes intersecting. So where does plane ABG, which is actually this front face, intersects plane, let's say this top face, EFG, which is here, right? EFG, we're talking about the top because that's 3 points that are on the top, that are with the top. Where do those actually intersect? If you look at where these 2 planes intersect, they actually intersect here. So I'd say along FG. And technically I'm going to say line FG because if you remember what I said about planes, even though we did put border lines on these planes, they do actually keep extending out. So technically this intersecting line extends out. That's kind of a little technicality, but basically you should know that they intersect right here along this line, which looks like a segment, but in reality, because these planes keep extending, we say that's why we say line. Okay, there's a couple examples there at the bottom. We'll look at sketch line AB and ray BC that are non-collinear and intersect at B. Okay, so we're trying to sketch line AB and ray BC, non-collinear, and intersect at B. Okay. So just kind of take your time on these, and if you screw them up, you just got to erase them and do them over. The key here is they got to be non-collinear. So right there. Okay, line AB, ray BC, non-collinear, meaning their 3 points are not in a line. Next one says sketch segment AB and BL that are collinear. Well, okay, AB segment and BL segment, if they're collinear, that means they have to be in a straight line. Okay, next one says sketch line AB and CD that intersect at E. That's pretty easy. We kind of did that already. Okay, that one's pretty simple. And then the last other thing there, and that third or the fourth example is graphing out some points. So make sure you're familiar with how to graph. It says for the points A is at 1, 2. So I would be really specific. A is at 1, 2. Remember that means over 1 up 2. B is at 4, 3. Over 4 up 3. And C is at negative 3, 1. Like that. It says sketch segment AB and ray CB. So segment AB is like that. Ray CB should go from C and have an arrow through B. So even though I don't know if those are quite collinear, but make sure you put that arrow on there for ray CB. Okay, and then some always, sometimes, nevers. Okay, it says 3 points are blank collinear. So you just have to think about 3 points. Okay, if I have 3 points, they could be collinear, but they don't have to be sometimes. 3 points are coplanar, so this is 3 points are blank coplanar. Well, I told you 3 points are actually always coplanar. 2 lines will intersect. Will intersect. Always, sometimes, or never. 2 lines. Well, they might not intersect or they might intersect. I'd say sometimes. Key is kind of drawing a little picture out to think about these. 2 parallel lines will intersect. Intersect. Okay, parallel means they never will intersect. And then a point on ray AB is also on ray BA. A point on ray AB is also on ray BA. Always, sometimes, or never. Well, draw it out. Here's ray AB. Ray BA would go here. So if a point's on ray AB, it means it's somewhere on here. Does that mean it's also on here? Well, it kind of is going to be a sometimes scenario, because if the point was here, it'd be on both. But say this point here, that's on AB, but it's not on BA. So I would say sometimes. It's a little trickier.